that one is muted. Okay. Well, I want to first thank everyone for coming today to this next in a series of inter-institute seminars. The idea behind this seminar series is that we can bring together a number of faculty and experts all across the university that may not have a day-to-day interaction with each other. They can now come and hear a very interesting talk, hopefully inspire some new ideas, and also maybe visit a building that you have never been to before. So on behalf of the Institute of Chemistry, I'm very happy to welcome today our speaker, Professor Valerio Schiavoni from the Institute of Informatics. Hi, come on in. So Valerio received his bachelor and master's and PhD degrees in computer science from the Roma Tre University in Italy and from the University of Neuchâtel, respectively. He was then a research engineer at INRIA Rhône-Alpes in France and also at Yahoo Research. From 2014 to 2017, he was appointed the scientific coordinator of the Center of Competence for Complex Systems and Big Data here at the University of Neuchâtel. And he currently coordinates the CUSO, the CUSO doctoral program in computer science. In the past, he has co-founded a startup called Safe Cloud Tech and also co-founded the ARM HPC user group. Valerio has published more than 100 articles, and his research interests lie at the intersection of systems broadly conceived, security, and data management. Here at the University of Neuchâtel, he teaches a course called Operating Systems, Cloud Computing and Big Data, Sécurité des Systèmes Informatiques, Technologie Web et Réseau, Software Skills Lab, and Outils Informatiques pour les Sciences. And with that information, I am very happy to pass over the microphone, and Valerio, you can begin your talk.
Well, I hope this one is working. Welcome, everyone. Thanks for attending. I'm very happy, very pleased. Thanks for the invite. Super happy to be giving this talk today. The title of this talk is Sustainable Computing, Known Facts and Hidden Figures of an Emerging Paradigm. So, before we start my talk, I would like to give you a little hint. So the carbon footprint that is needed to store the file in this presentation is 8.07 grams of CO2 equivalent. If you'd like to know how I computed this number, stay until the end of this talk. So the objectives that I have for you today is the following. First, I would like to explain to you what sustainable computing means. Then I would like to clarify how multiple elements in your environment are actually affecting the CO2 impact of your digital lives. Then I would like to highlight some known facts and perhaps emerge hidden ones regarding sustainable computing. I would like to provide you some examples, and then perhaps at the very end, if we have time, discuss a couple of little research ideas. First, let me give you a very broad definition of what sustainability is. One definition was given many years ago, in the 87, there was a United Nations commission that defined it as sustainable development is the development that meets the needs of the present without compromising the ability of future generations to meet their own needs. And if you look at Google Trends, especially worldwide, this topic is actually growing in interest ever since. I don't have data older than that, at least Google doesn't release that. On top of this, again, the UN defined what we call sustainable development guidelines. We will mention a few during the rest of the talk that try to guide the development of this topic in our society. Just to give you a rough idea how to read this, if there is a peak in interest, Google reports 100%. If there is no interest, Google reports 0. So it's increasing slowly and steadily. This would be worldwide. In Switzerland, the interest is also growing if you look especially through cantons. And in Neuchâtel is not so much of a hot topic, but in other cantons it was the case. If you look at the corresponding energy consumptions through Switzerland, you see that at some point there seems to be some increasing awareness that led to some decrease in the energy consumption of each canton. So this might suggest that there is some ongoing interest and some ongoing awareness through the country. Another element of consideration that I need to put in place before we get into sustainable computing is that also through the years, there are different energy sources used worldwide for many different reasons. And if you look at how they developed through the years and how they've been consumed through the years, you see that more and more energy, let's say green sources, are actually increasing through time. So this also suggests that there is an increase of awareness in this topic. So with this in our hands, maybe now we can talk about sustainable computing. There are a couple of definitions that I really like. One is from NVIDIA, which is one of the largest chip producers worldwide. They actually produce those big, expensive GPU cards that maybe you are using in your experiments. The first one says that sustainable computing is the practice of maximizing energy efficiency and minimizing environmental impact in the ways computer chips, systems, and software are designed and used. Quite easy to understand, right? There is also a similar one from, let's say, not a competitor, another big company, IBM, that says sustainable computing is design, manufacture, use, and disposal of computer chips, other technology components, in ways that limits the impact on the environment. Two are very recent definitions. And this suggests that sustainable computing actually affects a very big pipeline, a very long, if you want, supply chain, especially in the computing ecosystem, that affects how components are manufactured, how components are being built, how code is being written or developed, how these systems or data centers that run this code are being operated, and also the network that actually interconnects these systems. And the idea here is that sustainable or sustainability practices should actually span the full chain. So in the remaining of this presentation, what I will do is to try to give you some examples of how good practices in sustainability are actually affecting one, two, or some of these components. And to better understand, I'm giving you some small graphical hints. You will see there those green dots, and when you see one bigger green dot, it means that I'm talking about the first, the second, or the third, or the fourth, or the fifth component. But it should be more or less clear from the topic of the slide. The first is about environmental impact of the technology itself. We are more or less all aware that there is an increasing amount of resource consumption. Devices, data centers, even small electronics are actually big contributors in energy consumption. These consumptions are not so easy to quantify. One reason is companies do not necessarily disclose very clearly or continuously or perhaps accurately how much they are actually consuming. To put some numbers in place, in 2022, it was calculated that the energy consumption to run the internet, the whole internet, including all the data that is in transit, all the data that is stored, accounts for 800 terawatt per hour. It's actually a big number. So there is a lot of energy to be considered and lots of energy that has to be produced. Alongside that, one element that is important is what we do with e-waste management. In this sense, we want people to actually dispose of their devices in a responsible manner. We want companies, users, to be able to recycle items, recycle chips, and perhaps reduce their need of those chips at all. The big companies, usually these are referred to GAFAM, actually have a big role in this. I'm reporting some number in there. They actually, Google manages to sell in the second-hand market many items, and Amazon and other companies do the same. You can take a look at that URL. There have been actual nice attempts also to put sustainability practices into the hands of consumers. In 2012, there was this solar-powered keyboard. At the time, it was quite cool. Everything was wireless. Nowadays, it's normal for us, but it was still a solar panel in your hands. Then perhaps you might know this Fairphone, in which you can actually swap a large majority of the components, and this also, let's say, put into the hands of users some very good sustainable items, if you want. And there is also this other nice framework laptop in which you can replace the keyboard. You can decide exactly which components are going to be used. And in there, not only they encourage reusability and modularity, but also traceability. They put nice QR code on each of those components, and you can trace them from the moment they were produced until the end they are actually disposed. And these are, let's say, if you want, easy, or let's say somehow we are familiar with these items, all of us. There is another nice sustainable charger. For those who don't know, this one, it's a, let's say, plant-based energy charger. So you can actually produce energy out of a 7 × 7 square meter of plants. And you can check their website. It's actually very nice. This can be deployed over buildings and over fields. But the amount of energy produced can actually be used in practice nowadays for charging smartphones or smartwatches. Perhaps you don't know, but you are also using already sustainable processors inside your devices, inside your smartphones. You might have CPUs that are able to adapt to the energy needs that your application have and use less or more powerful processors according to the actual applications that are running on it. These are called Big Little. This is an example from the ARM CPU vendor, but there might be others. And there are also others of such processors that are available and on the market that are perhaps built on microcontrollers or on clouds. On top of all these nice devices and energy-friendly processors, we can actually build new type of applications. I'm going to show you a couple of classes of examples, 3 examples overall. One regarding animal species in danger, and others regarding events that might put in danger human beings. All of these applications are actually I'm actually trying to show you how these applications are going forward, supporting some of those United Nations sustainability goals. I'm only reporting examples from 2 of these goals, but there are 17 of them. You can check them out. All of them relates in one way or another to our life. The first example that I wanted to show you is regarding orca tracking. So orca are big animals, and they migrate, in particular, in this example, between the border of US and Canada. Nowadays, that border is a bit cold, I would say. And in there are 73, last time I checked it was 75, so 73 now of these southern resident killer whales. And these animals are tracked through hydrophones, which are kind of microphones that you put inside the water, and through the signals that are sent and received by those microphones, you can somehow build models that somehow are able to detect the health of those animals and route them somewhere. This is an example of trying to target how life on land and below water can be improved through these practices. And one reason for that is these devices have actually a very, very long battery life. It means that you need to buy new devices very often. It means that they somehow are resilient to major natural events or perhaps even catastrophic ones. You can take a look at the map of those hydrophones, and from that you can somehow infer, if you are good enough, where the orcas are nowadays. And there is a very nice project on top of that. There are some elements in there in which they model very accurately how those animals are moving. And I found this quite fascinating. Another example, so let's move from very big animals to very small ones, is about mosquito detection. And in this other example, what these researchers have done is to try to track the sound of, let's say, deadly mosquitoes by registering the sound of their wings. And then they have a lot of very nice set of devices spread through a given territory, a given field. They deploy these small chips, small devices, a few centimeters here, and they use easy to use machine learning libraries such as TinyML to build on top of that, build on top of the signals that they receive, and be able to detect whether a given invasion of mosquitoes is actually coming up. The third and last example that I wanted to mention, once again, this is for one of those UN goals. The last example that I wanted to mention is regarding tsunami forecasting. And once again, here the idea is to try to overcome the relatively short life of those dark buoys. I hope I'm mentioning this correctly. Here the problem that they had is that these big devices are quite fragile. They also seem to have caused one of the issues with the 2024 tsunami, and they were somehow broken, or there was a failure in the notification system, and then they want to replace these devices once again with these underwater microphones. And it's nice how you can actually see them live and tracking them and get all this data and analyze that. If you have questions, do not fear and interrupt me if you want. So we have talked about many small devices, and these devices produce lots of data. This data has to be stored, processed, and somehow handled by some usually big data centers. And to do that in a sustainable manner, we usually refer to sustainable cloud computing. There are other terms that more or less define the same area. You might have heard about green computing, for instance, which more or less is the same. You can imagine that such practices can be applied to scenarios in which you have different users that wants to run their application over the cloud. Here we have three users, the orange and the yellow and the blue. And then at some point they would like to better use the resources or somehow to achieve, to maximize or minimize the energy they are consuming. And you can imagine that one way would be to move the applications of all those users somewhere else, so that the energy consumption of those applications over the cloud are somehow reduced. So this is all nice and good, but then you still might wonder, what is the actual carbon footprint of using such data centers, or more in general, of the cloud? There are nice websites that report you numbers and you can actually play with. I encourage you to try this live demo where they give you nice simulation tools where you can simulate your applications for how long they are running, how many nodes you are going to use, and this gives you an idea of what are the costs in terms of CO2 footprint, at least, of your applications. So many details that you can actually use with these systems and then are quite accurate from what I've seen in some examples. Here, for instance, in this system, you see that there is an average CO2 footprint of roughly 2,000 on average. And to give you an idea, this is roughly the cost of 3 times round trip New York to London. Sometimes, in the best scenarios, cloud providers even release numbers regarding their carbon intensity. So given such geographically widespread data centers, where they're actually spending or more CO2. This is the example for the Azure data centers. The darker the color, the worse, and the lighter or the greenish colors, the better. As you can see here, Australia and Asia doesn't play very well. Similarly for Google Cloud, and even same for Amazon. So if you can, it means that if you can, whenever you're using the cloud, try to deploy your applications in those green data centers. It means your CO2 impact will somehow be lower. There are details regarding what we refer to cloud jewels and how data, memory, storage, and computing resources are being used. You can check out the details over there if you want. I'll be sharing my slides somehow, and then people who want to get all access to those URLs can do that. But this is all nice and well, but these are, let's say, the CO2 footprints of cloud data centers or cloud providers. But then the next question is, what is the CO2 of everyone's internet usage, mine and yours? So let's try to give an answer to that question as well. The first question that we can ask is the cost of CO2 related to our emails. I use emails every day. I don't know how many emails you actually receive or send. In my case, it's actually heavy, unfortunately. And these are some numbers that are, let's say, well agreed upon. There is a 0.2 gram of CO2 equivalent per email. 0.3% of the global CO2 costs are actually derived from email exchanges. And whether this is a spam email or whether it's a short email, whether it is sent or received from a smartphone, if it is a very long one, if it is an email blast where you're actually spending lots of time on it trying to get angry at someone. In general, I would say that professors are very sustainable in this sense. They write very short emails. And students, especially some of them, not so much. The emails are, let's say, emails are only one example. There is a very nice book I would like to suggest, what is the How Bad Are Bananas, which actually give you the cost of CO2 of everything. So it's a very nice reading, and I encourage you to try to find this book if you can. Another, beyond emails, we all know and use websites. So we can actually build, design, and publish, hopefully, low-carbon websites. Let me show you some examples that I found online. I didn't know these websites before, but there are ways to measure what is the CO2 impact of these web pages. And these are actually relatively low. So you might wonder, since we are at the University of Neuchâtel, what is the cost of our university website? I'm not going to report the raw numbers, but I did 2 tests. One, it was in January, and the numbers were so good. There was a rating. There are many more details that report this. And I checked again yesterday, hoping that things were somehow improved, but not really. So it means that it actually only means that there are room for improvements and things can be done in better ways. The website there actually can report these numbers for any website. What are these, let's say, web-oriented sustainability practices? Are well known. There are 93 offered by the W3C consortium, which actually defines the standards over the web. You can check out that and give you ideas on how you should improve your website, in particular regarding sustainability practices. There are some examples in which you can use, for instance, a wireframe or prototype better your websites, sometimes using better color schemes, using better web dev tools, and perhaps even hosting your website in a place where it is appropriate. Let me explain you a bit better what this means. There are web host providers that report numbers regarding their actual CO2 consumption and what is the cost of hosting those web pages through the year. This one is from a French provider, Scaleway, but there are others that do the same. And they report how much they have spent through the year to host a given web page. The number you see there is this power usage effectiveness. It's a well-known common metric that is used to measure the sustainability impact of a given machine in general or of a given service. The ideal value is 1. The Google data centers nowadays are not that far. Everything else is worse. These numbers are particularly interesting. It's not something particularly new. In the late 90s, eBay was actually offering some kind of dashboard that looked more or less like this. It's uglier if you want, but the numbers are exactly the same. So it's not something that is new in the sense of technical terms, but something that is more and more being exposed to end users. We might want to talk a bit more about sustainable data centers. Worldwide, there is an increase overall in the whole IT sector in let's say 5% or more. It is prospected until 2030, of increase in energy consumption. Large majority of it due to the increasing use of AI services, and part of it due to the move to 5G mobile networks. Nevertheless, the cost of power usage effectiveness, which is the ratio between total energy and the energy used by IT equipment, is actually stabilizing. These numbers are reported by Uptype Institute and are true worldwide, but also in Switzerland. There is a label that exists that was defined and created as an outcome of a EPFL lab and other industries, which gives kind of certification of whether a given data center is sustainable or is applying sustainability practices. They give levels like all certification systems, but I find it interesting as I still wonder whether the big companies are actually ready to try to pass those certifications. As you see, these numbers are huge. Just to give you an idea, the overall Switzerland entire energy consumption in 2023 was 56 terawatts hour. So if you combine a couple of those ones, you already have the consumption of a whole country. So these are things that you should keep in mind when you look at sustainability and sustainable data centers. There are nice practices that some companies actually put in place across, let's say, their whole the company culture. This is an example from an Italian company, the main electricity company, in which they actually provide guidelines that should be applied to all the activities that belong to a given company, or how they send emails, or whether they should turn off their machines and so on. So I found this as a nice example. Then we should think a bit more about social impact or social network impact on the CO2. To give you an idea, TikTok is very expensive, Reddit is also very expensive in terms of CO2, and the other ones are a bit behind. If you're using Netflix, you would be spending 55 grams of CO2 equivalent. If you're paying your milk with a Bitcoin transaction, you're actually spending a lot of CO2. So think twice about going on an electric bus while doing transactions with crypto coins, especially with Bitcoins. And then we should also think and talk a bit more about the carbon footprint of generative AI tools, which you all know. The first thing I would like to mention is nowadays 80 to 90% of the overall workload for users is what we call inference, so asking something to a given service. I'm taking aside the training of these models because large majority of these numbers are actually not disclosed. When we talk about these services, basically we refer to these kind of things. You ask a service to generate an image. In this case, once again, I have two examples to generate a cat that look at a Swiss lake. And when I tried last time, it took 5 seconds to generate that image. I tried again yesterday. It was a bit faster. So if you want, the CO2 impact of that generation improved. But you can do all these kind of things for texts and for other things. It is estimated that there are 400 million users using OpenAI or related services, and their CO2 impact worldwide is actually very big. And once again, this not even take into account how much it takes to train those models, which is expected to be orders of magnitude of that. So someone would like to do something about this. We usually refer to sustainable AI. In this sense, we would like to have AI systems that are somehow conform or try to match as much as possible sustainability guidelines, and in general trying to minimize their impact. And there were additional numbers that were reported in 2019 from MIT, as you can see, for a recent machine learning model or a transformer, there was roughly 6 times the cost of having a car in the US. So these are numbers that you should be aware of when considering sustainable AI services. Similar considerations can be done for governance, ethical, for instance, regarding AI tools for hiring, AI-driven medicine, and all those kind of things. They all come with a huge CO2 cost that should be somehow adjusted. The next thing I wanted to mention briefly is sustainable programming. Here at the university we teach programming languages to all or large majority of our students in the Faculty of Science, but not only. We all know and we all teach high-level languages, and if we compare what is their energy cost from C, which is the lowest level language, up to Python or Ruby or these high-level languages or programming languages, more or less we see that these languages are actually very expensive. This is the ratio between a specific language and the corresponding C, and the ratios are huge. There are good reasons for that, if you want technical reasons. One of them is that the amount of machine code that is produced by these high-level languages compared to low-level ones is that if you want to do a simple hello world in C, it takes few lines of machine code, and with Python, it takes many, many slides just to present you the corresponding machine code. Then I can finally answer the question that I asked you at the very beginning. How did we calculate the CO2 cost of these lights? I built this very nice machine. It took me 1.5 years. And then I designed this extremely smart and very complicated formula, as you can see, a bunch of multiplications, and gives you the CO2 cost of your file. Of course, it is a very dumb simplification of what actually is happening. But this gives you an initial idea. You can simply take into account the size, the carbon intensity for a given country, and then define some constants. Of course, this is more or less of a joke. There are more serious ones. One of them is this calculator at Green Algorithms. And this actually a very nice web service you can use. It takes into account the hardware that you are using, what kind of server you are relying on, if it's a local PC, some machine over the cloud, where you are, and taking into account all of this, for regular applications or also for AI ones. There are also systems that allow you to measure the cost of your code without using these services. You can import some Python libraries or some R libraries, and these costs are somehow computed with a given certainty. I finally come to almost the end of my talk. I don't know how we are with timing, I think it's good. I wanted to briefly mention a couple of things that are a bit closer to my area of research. One is regarding sustainable security, and the other one is regarding sustainable blockchain. Sustainable security is something that kind of new, if you want. Security in computer systems is, of course, exists since forever. But here we need to take into account and the trade-offs that exist when trying to match security and privacy constraints with whatever those sustainability guidelines and the constraints that are given are trying to match together. And for blockchain systems, which I will also briefly introduce next, you need to try to match the demand to reduce the energy requirements with the scalability trends that you would like to achieve. Briefly speaking, I usually refer to sustainable software security, and this is a system in which you want to try to preserve its operational mechanisms and its security despite unanticipated security threats. There are many attacks that come here. I just mentioned a couple of examples. Do you know what this is? Of course, it looks like a gun, but it's not a gun. It's an ultrasonic weapon that tries to send signals over microphones that might be in your smart home. And doing that, your speakers might be tricked to receive vocal messages that humans cannot hear. So this is some kind of things that might happen, that actually happened not that long ago. That one, maybe you have. It's a Google Nest. And a couple of years ago, some guys managed to hack those devices and increase the temperature of a house. So the problem is that to try to prevent or mitigate these attacks is not necessarily easy. The management of these devices is complex, and especially if you want to keep them operational while there are security patches to be installed. On top of that, sometimes to try to mitigate those attacks, you want human intervention. You want humans to be there, and you want their attention to be somehow, let's say it's substantial to maintain the security of these systems. So this is something that is somehow interesting for me. And then the other element that I wanted to mention is regarding sustainable blockchains. Blockchains, for those who don't know, are somehow distributed ledgers, and the nodes that are involved in managing or implementing these ledgers are somehow chained together. That's why it's called a blockchain. And you want these systems to scale more or less easily. And here the question is the same. You want to try to come up with a balancing act between the sustainability guidelines and the energy costs that you need to do that, in particular so that the nodes that are here manage to agree at reasonable costs. This is what is costly in general. So the takeaway of my presentation is that computer science tools do have an impact on the global CO2 cost that we can measure. We should be all aware of these costs. There are ways for us to measure that as researchers using computer science tools, at least. I've described few sustainable computing practices can help us to do that. And then I hope that you will try to build better sustainable software in whatever research you are doing. Thanks for attending. I'll be happy to take any questions if you have, or now or during the apero. Thanks a lot. Yes?
I was